Welcome to myprojectbazaar.com. Our product title is a new multi-input 3-level DC to DC converter. Let us see about abstract of our product. A multiple input DC to DC converter is useful to obtain the regulated output voltage from several input power sources such as a solar array, wind generator, fuel cell and so forth. A new multiple input DC to DC converter is proposed and analyzed in this implementation. In this proposed implementation is based on a new multi-input isolated 3-level converter for renewable energy and sustainable energy systems adopting high DC link voltage. Multiple DC sources are integrated to the 3-level DC to DC converter before the isolation stage, resulting in reduced part count, determining DC link voltage level and allowing flexibility in transformer design. The proposed architecture eliminates two boost switches which are present in the two-stage counterpart. The input inductors are operated in discontinuous conduction mode. Thus, power can be shared between input sources through proper selection of input inductors. A low voltage prototype has been designed to serve as a proof of concept. The proposed topology is capable of energy diversification among different energy sources with different voltage current characteristics while achieving low part number and bidirectional operation. Next we see about flow diagram of our product. This is our flow diagram. In this flow diagram the first one is a input source. Here having three input sources. That sources may be a solar generation, PV cell and fuel cell and also battery, and also three sources are fed into second level converter through a passive elements. First of all, the input sources is a first level, and after that converting, that second level converter is DC to AC. That second level converter is connected before the primary winding of the transformer. After that transformer, the third level converter is connected between the resistive load. In the third level converter is consist a passive elements, and also it convert AC to DC. Generally, the proposed multi-input converter is essentially based on the operation of the 3-level isolated DC to DC converter. The secondary side rectifier can be either a half-bridge rectifier accompanied by a tapped winding for the low output voltage applications. Since the PWM schemes here is too similar to that in 3-level converters, the control complexity is not intensive. The post inductors connected to the input source of the different voltages are charged when S2 and S3 are turned on respectively. When the related switches S2 or S3 is turned off, the energy stored in the inductor is transferred to be the load. The overall process having similar advantages such as efficiency is high and constant output voltage is obtained and low switching stresses and multiple sources are used and conversion efficiency is high. So overall efficiency will be increases. Generally the sources having in 3 level, the input is DC, after that in the second level converter that converted into AC, after that AC supply is converted in the 3-level converter into DC. Next we see about running process of our product. In this proposed implementation is done in MATLAB simulating environment in the version of 2013A. First to open the MATLAB window and create the new model file. After creating the model file, we arranging the elements as per the circuit. After arranging the circuit as per the base paper, we click the run icon. After clicking that, the output voltage and current waveforms are shown in the corresponding scopes. First one is the upper voltage source corresponding current waveform, and this is the corresponding voltage waveform. That voltage level is 25 volt, and next one upper second source voltage is 50 volt and corresponding current waveform, and next one is the upper third source voltage value, that is 100 volt and corresponding current waveform, and next one is the lower third source voltage, that is a 25 volt and corresponding waveform, and next one second, that is a voltage value is 50 volt and corresponding current waveform, and next one is the first voltage source in the lower side, that value is 100 and corresponding waveforms, and this is the primary side of the transformer output waveform, and next one the secondary side of the transformer output waveform, and next one is the corresponding output current waveform in getting in the resistive load side, and next one is the corresponding output voltage that is getting from across the voltage of resistor, and next one is the corresponding space vector signals. The overall efficiency will be increased due to the reducing of the switching losses. So overall power density will be increases. Thank you for watching this video.